Okay, very warm welcome to our audience today. This is Tim Matthis and I'm sitting with Josh Chettiar, and welcome to the inaugural episode of the Superhumans AI podcast, proudly brought to you by IQ Business. It's a really great pleasure to have you listening to us today. And today's episode is very much an orientation of the podcast and a discussion about all things AI and what is AI and what is this huge hype all about. I'm the managing partner of the Solutions Business Group and extremely excited to be working alongside Josh Chettiar, who I have a fairly long commercial history with or working history with, but I'm going to hand over to you, Josh, to introduce yourself.
Thanks, Tom. Thanks for the introduction, and hi to everyone listening. Of course, I'm Josh Chettiar. As Tim said, I'm the pioneering member of the AI Lab at IQ Business. Really excited about this podcast and all conversations AI.
Yeah, that's really super. So maybe the place to dive in, just a tiny little bit of housekeeping about what we're doing in the AI Lab and what the AI Lab is, and then let's jump into today's episode. But for those of you that don't already know, the AI Lab is a new area inside IQ Business where we really aim to deliver value to our customers and our IQs across 3 different dimensions. And those dimensions are consulting, and consulting is very much helping our customers understand the risks and opportunities associated with artificial intelligence, how to harness all of the hype, how to supercharge their teams, also how to manage the risk with both to their businesses from a threat perspective of what other companies who are embracing tooling faster than may look like, as well as also getting AI wrong. I think there's quite a lot to be done there. The second area is very much around product development. So we're very excited to be building out and prototyping some products using a range of technologies, which we can talk about in a little bit more detail. And then the final area is really thought leadership. So engagement with our customers, bringing them into events that we host. This podcast is a mechanism to interview interesting stakeholders, people who've got things to say across any different domains. We anticipate that in the future, we will interview people in learning and development. We want to understand people in the psychology space, agility, software development, pretty much every one of our lines of business to understand how they see and how they're embracing artificial intelligence. So please, if you have anybody interesting you'd like to put forward to the show, or you'd like to come on as a guest, we'd love to talk to you. Okay, great. Josh, maybe you can help us by unpacking just a little bit about the tooling around the product side of AI. What sort of tooling landscape are we looking to use? How do we think we can engage with our customers from a tooling perspective as well? And if I'm an IQer sitting around wanting to get involved, how do I do that?
Great question. So I think while we are mostly tool agnostic, I think the Microsoft stack, particularly Azure and Azure Cognitive Services, is what we at the IQ Business AI Lab will be primarily working within, as well as a host of other open source frameworks from LangChain to Streamlit, which enable sort of the quick prototyping of LLM-driven applications. So it's usually it's really just those two, Azure Cognitive Services and a range of open source tooling that we will be using.
Okay, great. Thanks very much for that. Maybe best place to start here is for us just to give our audience a little bit of a orientation as to what we are talking about when we talk about AI. AI, as we know, hasn't been around. It's not brand new. Different types of AI have been around for quite some time, but there's obviously been an incredible resurgence and uptick in interest. What is it when we talk about AI that we're talking about these days specifically, and why the hype, Josh?
Yeah. So I mean, it is true. You probably heard the sort of phrase or statement, AI isn't new. And that's both a true, well, I would say that is for the most part a true statement, but it's one that has to be caveated with some with some distinctions. And that is to say, yes, we've had AI since, I would say, the ideas of AI and mechanisms of AI from the 50s and 60s. And essentially what that is from a definitional point of view is simply sort of the computational means, or within silica, the ability to approximate and achieve proficiency in tasks that would otherwise require human intelligence. And we talk about human intelligence, we're talking about aspects such as understanding, reasoning, planning, decision-making, response, etc. And if you think about the sort of sophistication of that, you can imagine it sort of ranges on a dimension from very narrow, specific on one end of the spectrum to a very sort of broad, general abilities on the other end of the spectrum. But that is essentially what we mean by AI, is sort of the computational approximation of those tasks that would otherwise require human intelligence. And within that, there are things like machine learning, which is really just one method of achieving these, achieving the sort of proficiency. It's been the most successful method, particularly since the 90s. And what it is essentially just using past experience to infer future trends. So the sort of key thing here is the second word in the phrase, and that is learning. How can we build models that learn from the past to extrapolate into the future? And so that's sort of your AI, that's your machine learning. But what is it that has taken over the world right now and sort of become top of mind? And that is generative AI, and that sort of goes into the world of large language models. And in a nutshell, generative AI, as a subset of AI, is concerned with producing new information, be it text, be it images, be it video, given some natural language input. So it takes some natural language input from the user, and then in turn generates some content that is quite realistic or human-like in sophistication, be it further text, be it an image of an artwork, if you will, or be it even in some new advances, be it music or be it video, and that is what generative AI is, and it's sort of been enabled by the transformer architecture, which is just sort of a breakthrough that the Google Labs had in 2018, which is to sort of build a model that has the sort of sophistication needed, things like attention mechanism, etc., to enable this.
So I think it really is the thing that's captured the audience's, the world's attention, is this sort of step change that's happened where we've gone from quite impressive sort of at core machine learning algorithms to suddenly being able to have a conversation with a bot that seems like a human. That seems to be the really big thing. And I think what we're finding is that the application for this is really vast. We talk about sort of a general purpose technology. We're finding more and more ways to weave natural language, this tooling that we have now in natural language, into other automated tasks. And I'm sure we'll talk just in a very high level a little bit about things like LangChain, which puts language into a chain of automation. But really, that's the thing that's happened. I'm going to have a quick stab at trying to describe how we do that, because there's some stuff that's both mystical and then also quite profound in its simplicity in these large language models. So I suppose the first thing is that at its core, and this is a misperception, I think, out in the market, large language models do not contain all of the knowledge of the internet. What they actually do is just predict, given any starting word or set of words, what the most likely next words or phrases are to be in a model. And that's quite profound. So when you type into a large language model, say, can you tell me what the weather is in what the climate is like in whatever it might be, Reykjavik, in October, what the model's doing is going back to have a look in an approximation, a model which is basically a collection of numbers. The whole thing is just built up on a series of numbers, and it's trying to find out something called the nearest neighbors. So it's trying to find out what the most likely next words are associated to those words that you put in. And it's quite profound that just by sort of determining what words are mostly associated with other words, you can get to this level of production or generation that looks very much like human intelligence. So super interesting. I think misperception number one, these large language models contain all of the knowledge that's on the internet. They don't really. They're a model that has been built from all of the knowledge on the internet. And that model is just a series of numbers. They call these vectors, and the vectors just describe how closely associated words, which may have similar other words in them. So inside a vector, you might have words that have got similar contexts to them, or words that are often occur together, or phrases or letters. And that's all it is. It's just distance from one to the other in a large vectorization of the world's knowledge. I don't know if that made things more confusing or simpler. Josh, maybe you can try and simplify that a little bit more for our audience.
Yeah, no, I think you are quite correct and explained it quite accurately. It is in a sense just predicting the next word. I think some of these large language models try and predict not necessarily the next word, but the missing word. I think that's just sort of a distinction between autoregressive and autoencoding models. For the sort of early LLMs like that Google built, like BERT, etc., were autoencoding models. So they use something called masking. So they would give it a bunch of text, maybe from the internet. I think BERT gave it from Wikipedia and a variety of books, and it sort of hid the word, that's masked the word or blocked the word, if you will, from the AI that's within a sentence. And so the AI has access to both what's before and after that word and tries to predict what's in between. But in the case of GPT, definitely that is just purely trying to predict the next word, given what the user has inputted as an instruction or as a prompt. And it's sort of been trained on the vast amount of internet. That is to say, the model's weights have been adjusted in response to the sort of training it has been, the training data that it has been given, which is, in the case of GPT, the vast amount of data from the internet. So that you are correct in that distinction. And I think what I would like to also just touch on here is sort of why this fact makes it so different from the previous generation of AI. And that is to say, when you often hear companies say AI isn't new and we use AI, it might be the case that that is true in terms of what they are referring to as AI. But just as someone from who's previously been in the insurance industry, for instance, a machine learning model that's actually running a logistic regression to predict credit rating, for instance, is by the technical definition AI and machine learning, but isn't the sort of sophistication or type of AI that we're talking about here when we talk about large language models and generative AI. While definitely useful and definitely impactful within the space, there's a distinction between the sophistication that this very fact can bring because of the understanding of semantics and with that's contained within human language that this sort of approximation can achieve.
Yeah, that's fascinating. And I think the thing that really captures everybody's imagination here, and I think when we start to talk AI and get people excited, it's what I think we really allude into is steps towards what's called artificial general intelligence. We're really trying to build computers here that sound like and are becoming more and more indistinguishable from humans. So to my mind, at least when we talk about LLMs, what we're doing is starting to get towards, let's call it general purpose intelligence. I don't think we're quite there, although by some tests, these large language models seem to, they seem as if they're logicking, they seem as if they're able to perform intellectual tasks across a pretty wide array of different dimensions. But they're not quite AGI, but they're certainly a step towards that.
Yeah, so, you're right there. I think you go into sort of the degrees of sophistication, AGI, artificial general intelligence. Some also refer to super intelligence. I think what's important here is from the very basic mechanism that you described, predicting the next word given some context. There's a lot of emergent properties, sophisticated properties that have emerged from this that I think is worth pointing out. And I think it is in fact the same of human intelligence, that there are certain basic constructs on a neural level, on a biological level, that perhaps are quite simple to comprehend and understand on their own, but when combined and when sort of merged with other concepts, evolve into this emergent ability. And I think what is quite fascinating is the sort of research that is coming out almost daily that attests to some of these emergent abilities of large language models. I refer to, for instance, a paper I read recently, and I can't remember the source right now, but we'll certainly include this as part of the notes of the podcast after the fact. But one study compared the ability for a large language model to come up with novel use cases of common objects. So there's a specific name for this type of type of challenge, and basically gave it to humans and then gave it to GPT, take a cup, take a chair, and suggest, for instance, novel uses of this beyond just the obvious. And what they found was that the best humans came up with better solutions on average than the language model. But on average, the language model came up with better solutions than the average human. And I think that's quite interesting, in that the sort of those on the tail end of the curve, extremely sophisticated humans, shall we say, did outcompete or come up with better solutions than the current version of GPT. But when you talk about the game of averages, GPT was still better than the average human. And I think that's quite quite an important or interesting fact.
So I suppose the one variable that you got playing out in the human population is obviously genomics and the fact that no two humans are the same. So I mean, I don't find that all that surprising, and I think what we could probably predict into that is that mean will move forward. The mean average intelligence and ability to produce to function well in any task in these large language models will only continue to improve. So I can well imagine a future where that mean starts to get into the last, whatever it be, the standard deviation of the human IQ population, eventually far surpass it. It would be interesting to know whether or not you can create the same variability in models by under and overtraining them as you do as you get in human populations. Josh, what's your view on that? I mean, when we say that these models on average produce results, the range of results they produce is more centered around the mean. Is that what I'm hearing you saying? And the range of human results is more, there's a higher standard deviation, effectively what you're saying. And where does the mean lie? The mean of the artificial intelligence, large language models at the moment lies ahead of the mean of the human population. Is that correct?
Yes, that is correct. Yeah. And I think it comes down to, of course, as you say, it's probably not surprising given that it has been trained on the entirety of the internet and is therefore more likely to produce some value closer to the average of that training data or beyond, given that it hasn't only been trained on that data, but has gone through subsequent refinement and human reinforcement learning and so forth. And I think, that is definitely going to be moving, that means going to be moving to the right. And that's what many companies are essentially engaged in right now, the challenge of how do we take these base LLM models and improve their abilities either on their own or in combination with other mechanisms.
So it's very interesting. As I engage with a lot of people on artificial intelligence, and we do more so with customers and then also sort of colleagues, I'm very often, I find myself faced with a very similar response, and that's one of almost opposition and fear from people. And the conversations that I hear are very much around protecting what is human. People sort of say, surely machines will never be able to be creative. That's the one that you hear most often. It's like somehow creativity is, to the exclusive, it's an exclusive realm for humans and not for artificial intelligences. I mean, maybe we should just spend a couple of minutes understanding, this is I think it's natural for people to feel afraid because machines are potentially starting to do what humans do. But where is the magic thing that makes human intellect fundamentally different from machines? Because it seems to be the place that everybody goes to. Everybody wants to find out that bit that makes us unique, that AI will never be able to touch. What are your views on that? It seems to be, I think, a way for people to reassure ourselves that we're never going to be replaced ultimately. But is there something special? Is there something that's truly emergent about human intelligence or somehow non-replicable? And I know that Noam Chomsky's got some views on this. Maybe you want to touch on that and some other thinkers. But what is innate about human intelligence?
So it's undoubtedly a subjective question and sort of calls back to or refers to one's own philosophy and ontology and framework. But I think one can become very metaphysical in these arguments and to varying degrees in the search for what makes us distinctly human, if such a thing is if such a thing indeed exists. I think I would prefer to, if I was to delve into this, to concentrate perhaps on certain less metaphysical facts, such as the fact that these language models or any AI right now are currently disembodied, which means they aren't physically connected to the world, which is a distinction from humans. And I think that feedback loop between sort of the environment and the cogito, or the entity that's thinking, I think is something that's distinct. And perhaps there's something within the wetware of the human biology that is far more sophisticated. And I actually think this is perhaps a given, that there is something at the sort of neural or chemical level that's more sophisticated computationally, nevertheless, than the neural networks and deep learning neural networks. However, I don't think these things are beyond science or beyond discovery. And I think that's sort of a distinction I would make, that I wouldn't point to any sort of metaphysical fact beyond just those two, in my personal opinion.
So maybe something to pause on there is just a moment of awe about how incredible the human brain is as a computer. And so I think the human brain, and you'd have to sort of check my numbers here, but I believe it runs on something like 30 watts of energy. Whereas if you take the amount of power that's been used in the data centers to run something like GPUs, the GPUs that are running the full stack for GPT, you're probably talking about megawatts of power, so thousands of kilowatts of power. Whereas you've got this little bit of wetware in your brain that can produce computations that are, at this stage, far superior to what you can see GPT running on 30 watts. So there's something really unbelievable about the way that the human wetware works. And then we're talking about the base unit being the neuron, and the neuron sort of having this polarization effect that helps it to fire off and connect with other neurons, which are synapses. And I think we still don't fully understand that, although what we're building in large language models is an approximation of how that's assembled in the part of the brain called the neocortex and pattern recognizers. But what strikes me here is that in evolution, and I'm going to go back to evolution, I've got a background in evolution, there's something called convergent evolution. And convergent evolution is the idea that you can arrive at the same end, the same fulfillment of a niche in nature, without running the same hardware. And then some of the examples that they give are the eye of the chameleon versus the eye of the octopus versus the eye of the human. And in all three of those three designs evolved independently over the eons and millennia against the same evolutionary forces, starting off with some photosensitive cells and then the requirement to focus light using some form of sort of optical mechanism. And if you just think about the chameleon eye versus the human eye, and the human eye, you've got the lens, you've got the cornea, and then you've got the lens that actually bends the light so it'll focus on the back of the pupil. Whereas in the chameleon eye, you've got something more akin to a pair of binoculars, where you've got a lens that moves forward and backwards. Performs exactly the same function, and experientially, you could argue that for a chameleon and for a human, the end result is exactly the same. They can see the world. And when you look at large language models, these large language models are producing what looks exactly like spoken text. And if you take away the idea of there being a conscious agent on the other side of producing it, it's almost indistinguishable. The conversation that you're having with a large language model, which is really just using these massive series of weighted or pre-trained transformers, as they call them, which are just arrays of numbers referencing back to words and letters. That's probably quite different to what's going on in the brain, but the result is exactly the same. And I would argue that this is sort of just another example of convergent evolution, but much, much faster. And at some point in time, we might arrive at something which is indistinguishable from human intelligence and superior to it, even though it's not done the same way. And maybe in the future, if you believe the guys who are getting serious about this dystopian future, these AIs will start to evolve themselves, and we'll reach this point called the singularity, where they can become recursive and they can rewrite their own code, and they might even escape out of their kind of silicon jail that they're in at the moment into something else. But let's move on to this race for supremacy that's happening between Google and what's happening in the world at the moment. I mean, the governments are getting involved. Obviously, big tech's getting involved. There's this regulatory war that's getting played out between the likes of Sam Altman and the rest. You're hearing lots of people saying that we need to get a, sort of moratoriums on AI and moratoria, whatever the plural is there. And then you've got the sort of conspiracy theorists to say that as soon as the big money gets behind lobbying for policy changes, you can be pretty sure that regulatory capture is on the way. But just give us a landscape in here. Who's who in the zoo, and what does the future hold with big tech and government, Josh?
Yeah, certainly. I think it's a bit like the Wild West at the moment, with the sort of explosion of technology, and as always, the policy follows from the technology, and in this case, many of the proposed policies are actually coming from the companies themselves, be it OpenAI or Google. But I think what's really important here isn't just who's going to win and become the sort of the Apple of the LLM world, so to speak. But it's more about the winner determining or dictating the sort of design philosophies, the architectures, how we engage with these going forward. I think they have very different ideas. I think Meta, under the for those listening, they're the holding company for Facebook, or the company that created Facebook, and they have a guy called Yann LeCun, who's a French computer scientist. He was one of the architects of the convolutional neural network, which in basic enabled things like document scanning and handwritten text being being transcribed to some sort of structured format. He did a lot of great work in IBM to create these convolutional neural networks that made them enable this fact. But he moved on and joined Microsoft, then Meta, Facebook, then Meta. And his ideas are very different from Sam Altman's, for instance. See, his ideas are, it's the sort of technology is, it's not suitable to constrain these behind paywalls, behind or anything other than just pure open source. And that includes everything down to how the model was trained, what data it used. They're very open about these facts. And they open source a lot of these leading cutting edge technologies as they are developed. If you move over to the likes of Microsoft, who've recently bought over OpenAI, or brought in OpenAI into their under their wings, they'll, despite the name having the word open in it, they've sort of reversed course a little bit over the last few years, and they're very, very specific about what information they release to the public regarding how these models were created, the types of data that went into it. And so, and of course, you have Google on the other end, who are with their Gemini model. They're working on this new model that they claim to be the game changers. We wait, obviously, with bated breath to see what comes out of there. They were obviously the pioneers of this technology back in 2018 with the Transformer architecture. So it will be interesting to see what happens with each of these models, whether we'll end up with an open source model, one that's a little bit more closed, one that has to perhaps go through some regulatory checks on the sort of checkbox before they release to the public through communities of experts like OpenAI are suggesting. And so how this game evolves and how this turns out is really sort of the best interest of everyone, I believe, because I believe it's going to be one of the most important battles, if you will, of the 21st century, I think.
Maybe two scenarios here to contemplate, and then I think we should move on a little bit just to what this means for all of our listeners. But the two broad arguments. Argument one, big tech and big governments own AI. And the argument goes along the lines of they hold the intellectual property, of course. They've got all of the world's cleverest people that just buy them, and then they've got the machinery to run it. As a result, the productivity gains that are captured through these models, which we just seen I'd argue we just seen the very first, proto-species of what this might look like in the future. They're going to do all the jobs that all the white collar workers did. They're going to be the lawyers, they're going to be the doctors, they're going to be the diagnosticians, they're going to be the actuaries, data scientists, you name a discipline. They're going to be done by these large language models for bears. That's the right word. They're children of the large language models, and all the productivity that goes with it would then naturally flow to whoever owns the AI. That leads to sort of this dystopian future where the big tech companies around the world mop up the rest of the economy. I mean, it's quite frightening, but effectively look at it as a land grab for every white-collar job on earth and all the productivity that would flow to them. And you get this incredible bifurcation. You have, Apple at once was the most valuable company on earth, but can you imagine what any of these businesses who own AI would look like if they owned all of the other white-collar jobs and all productivity? That would be orders of magnitude bigger than the biggest company ever, and that would create a further wealth divide. History has obviously taught us that wealth divides are not good things, and they lead to social unrest. And if you want to take that idea even further, they lead to the collapse of empires. So that's scenario one. Scenario two is that we probably have the first opportunity ever in the history of mankind to get to a state of almost like worldwide abundance. If these tools are owned by socially democratic governments who redistribute wealth, and the tools do all the work. I mean, I can see you cringing as I say the word government. I cringe as I say it too. But if we could find a way of open sourcing these things and redistributing the wealth, we truly could be at the dawn of an age where for the first time ever, the concepts like universal basic income take hold, and that wealth flows out to the entire world. We could have the robots, let's just call them the robots. They could be helping us with our medical needs. They could be helping us with our farming needs, our food production needs, our everything, from start to finish, all the jobs that people do right now. And we could enter into this incredible golden age, and who knows what it might look like. It might be a terrifying age as well, because it would take away the need to work. But in those two different evolutionary paths, Josh, what are the forces that would stop either of them happening or make them more likely? I mean, I can think of one obvious one, which is the resources required to run the models as a starting point. How important is it for big tech to own that up front, knowing that what happens in history every time is that the tech gets exponentially cheaper and more commonly available, and the supercomputers that are needed to run these things right now, or the data centers required to run them, that might be a handheld technology in the not too distant future. So how much does that initial tech advantage matter to your mind, and how much will it determine where the wealth goes? I'd love to hear your thoughts.
I think within bringing further context of global warming into the picture here, I think you pointed out the fact that if you compare the human brain to the most sophisticated computational system right now in large language space, be that GPT or other, there's obviously a massive amount of energy that these computational systems use, seemingly contributing, or definitely contributing to global warming, and that's something that needs to be addressed. And I think some entities like Meta actively have research in these areas, because I think the closer we get to that point of no return, if we haven't already, from a global warming point of view, the more pressure is going to be placed on private companies through policies of the government to curtail or come up with different means to train these models using different, more energy efficient systems. And I think that's going to be a big one, particularly within the backdrop of global warming. And so that's one. And I think the second is the sort of expansion back into the space race, reigniting the search for new resources, new minerals. I think is an interesting one, with India and China expanding their space programs. I think it's beyond just for the novelty's sake. I think it's for mining valuable resources, minerals, etc., that could be used potentially in the manufacture of different new hardware. But just if I can also just go back to something you said between between A and B there, to bring Noam Chomsky back into the picture. I think he has for many years pointed out the risk of that first fact becoming a reality. I guess he calls it anarcho-capitalism, or sort of the marriage between anarchism and capitalism, where you have private industries, kind of like the Robocop movie, private industries running everything from the police to everything else, and it becomes who can pay for these services and who can't, as opposed to what someone like the philosopher Slavoj Žižek talks about, a new communism. And I know that's a word that will make people cringe even more than government, and that is the idea that if we face challenges like within the spheres of AI, bioethics, global warming, these are problems of the commons. These are problems of the masses, and it can only be solved through collective problem solving between private industry, between governments, between new forms of governments potentially. So yeah, I think it's hard to say which of those two we would go towards. I think there's a lot, so many different variables and factors to consider. I think, but it's certainly an interesting one.
Well, I think what we can say for sure is that we know how governments have acted in the past, and we know what human nature is. There'll be a strong evolutionary force towards grabbing power. that seems to be an impetus all on its own rather than anything else. What we also know is that for the first time ever, it's possible. It's probably, or at least it will be possible soon, for us to enter into a world where there's superabundance. So I think something to be optimistic about, and then also something to be really guarded about. Let's touch just for 1 minute on this idea about containment, because I think that when you start to lay this out, and I know we're getting sort of ahead of ourselves, and we're probably getting ahead of ourselves somewhere between 5 and 35 years, but we can be quite sure that it's probably not 100 years. So this is really, really soon what we're talking about when we look at it from a sort of a more abstracted perspective on the human timeline, or even on the timeline of our civilization. But I can see how people just want to dig in and say, like, no more, make it go away, don't do this, I don't want it. There's this idea that they talk about in AI circles called containment. Let's just discuss that really quickly. So what is the containment debate about, and where do the chips fall on containment?
Sure. So containment's all about how can we either slow down, have the ability to slow down, or turn back, if you will, these AI systems if it seems like their goals aren't aligned with ours, if it seems like they are on a road to producing outcomes that are against our wishes, if you will. But how can we either put the genie back in the bottle, or rather slow the progress of this genie? And I think if we define it purely as how can we put this back in the genie back in the bottle, I think that ship has sailed. I don't think we are able to put this technology back in, or to pass widespread policies banning the use of transformer models, business, etc. I think that'll be quite draconian. I don't anticipate that bar some obscure country perhaps on that level, but I don't think that's possible. But if by containment we mean the ability to steer, I guess the curtailment, I guess I would call it, of AI, in terms of the ability to build in mechanisms to switch off an AI, or to disconnect it from the larger system within which it's embedded, to put a human in the loop where one didn't exist previously. I think if we mean by that containment, I think there is some good work that can be done there. I think it's certainly important for both private industry and government to look at these measures to curtail the sort of impact of AI if needed.
Absolutely fascinating. And I'm sure we have many more debates going into the future around just this and where it's all going to go. And will be, some of our predictions will be horribly wrong and some of them will be right, but it's always nice to make those predictions. But let's bring this all back closer to home as we kind of wrap up. I mean, I think the first thing is to talk about our community of practice. So internally, we have launched a community of practice. We'd love for you to get involved, come and engage with us, chat to us about how that works. But we want people to lead from an AI point of view, bring AI into whatever your line of business might be. And we also want people to be learners and practitioners, looking at the coding, looking at the tooling. Just another reminder, we are a Microsoft data and AI partner, so extremely excited about that. And we'll continue to iterate our offerings and work with Microsoft directly as we build solutions and tools for our customers. And we'd love to hear from you on that front as well. Yeah, great. I don't know, Josh, if there's anything else you want to say to sort of wrap this up, but it's been a fascinating first chat. It's obviously been a very high level overview of where we are in the world and what this big AI thing is all about.
Thanks, Tim. Yeah, nothing to add. I think great chat, and looking forward to all future engagements with everyone.
Wonderful. Thank you so much for listening to our first pod, and you will be able to find many more of them with many more interesting interviewees and conversations. And hopefully these will be flown on a cadence of at least once every 2 weeks, but we hope to increase that to once a week soon. Have a wonderful week. Cheers from us.